Hi, and welcome to Scaling Networks, the introductory chapter to this course. And in it, we are going to talk about how to scale networks from a small business type application up to a large, growing enterprise device that you might see. We'll study images like the one pictured here. As businesses grow, as noted, all the applications are going to be growing and becoming more complex. The network traffic will be converging from different offices or maybe different acquired companies. There will be different types of businesses that might come and go. So all of this has to be planned for, and hopefully from a centralized business area, centralized administrative control. Now you've seen this model with the core, with the data redundant links here, managing all the traffic to the web very quickly between the distribution layer switches and the distribution layer where our policies are set, our access controls are met, and then the access layers where the people come in. We'll be looking at different ways to manage different layers of the core distribution and access. Mostly we're going to talk about access and distribution, focusing on distribution and switching. This is a fairly complex diagram of an architecture for a campus edge. And here we would have a server farm down here, and then within the building we would still have the access layer in the big enterprise campus. This would be a huge warehouse and an office park that the public doesn't come into. And then the enterprise edge is also has access to the four areas for e-commerce, okay, and internet connectivity, and VPN access, etc. So these are all coming back from the main campus. So the enterprise edge manages these services, and the enterprise manages and perhaps stores data and provides server services. Notice too in this, so I won't go too far into it here, redundant ISPs, because redundant links aren't just important, but redundant services as well. And then, of course, over here is the remote where you and I would enter that network. So planning for redundancy means buying duplicate hardware, providing redundant paths, and also managing for the spanning tree protocol, which we'll study in another chapter here. So the redundant links are really key because we want to have what we would call a failure domain. And inside a failure domain, well, let's also talk about increasing bandwidth with link aggregation. That's some of the first exercises we'll be doing. Would be ether channeling, where we take physical links and make them one logical link inside the switch so that the backplane bandwidth from the router, the buffer areas and the switches are pooled, and data can flow much faster. Instead of being managed as, say, 4 ports, it can be managed as 1. All right. So, and I wanted to mention too, let me step back, the redundancy also creates a failure domain. And a failure domain is simply a place breaking the network into parts where one device, the failure of one device, has minimal impact on the business activities. So the disruption to the workers is poor, the troubleshooting gets easier because it's minimized, and it isolates the trouble into one area. So a failure domain, you kind of plan for failure. Things are going to fail. The idea is to fail well. And that's what you'll read about failure domains in this chapter. Now, OSPF is one of the protocols that we've studied in the past, and we're going to look at it a little bit deeper this time around. We're going to use multi-area because we've just been using area 0 between a couple of routers, but now we're going to expand that between 2 different areas logically, so area 0, area 1, etc., and look into the idea of border routers. So that's managing OSPF traffic as it scales. One reason why OSPF is popular is it can grow, if you have 50, 100 routers, etc. We'll also be looking at different kinds of switch platforms. A new concept in the last year or so is cloud managed switches, the Meraki, Cisco Meraki, etc., and the virtualization of networking. This is all on the fourth. Soon enough, we'll be merging switches and routers. They'll just be one device, much like old PCs used to be many components, and now it's just one motherboard. That will probably be the direction switching goes as well. But for now, we'll be studying the different types of switching platforms. And we'll be looking at little nuances in switching, like port density is simply how many ports that you can pack into a tower, either 24 or 48, or perhaps a modular with all kinds of ports in it. But the port density is different than the forwarding rate, so we'll be looking at that too. The forwarding rate is how fast can a switch push out. Just because it has 48 ports doesn't necessarily mean it can forward at 48 gigabits per second. You would want it to, but switches at the access layer really don't need to forward that much anyway. So you might have forwarding rates that are smaller at the edge and save your money for the big switches, like the one up here in the top. Sorry, for the enterprise where the fast switching needs to go. One concept that we'll do a little bit in Packet Tracer, not in NetLab, is power over Ethernet. You've probably seen this if you talk on an IP phone that doesn't seem to have an outlet device. This because the configuration with a power over Ethernet switch, which is quite a bit pricier than the average switches, but it can save you a lot of money in cabling and trying to run power to access ports and phones. Access ports are hidden up in the ceiling sometime, and it's a lot easier to just run an Ethernet cable up to that access point and let it get power from the switch instead of trying to run an outlet way up and manage power inside the building. And again, I told you multi-layer switching, RSMs have been around for a long time, route switch devices. In fact, technically, a router is both a switch and a router. It determines a path for traffic and then switches it out the port where it's going. But routers and switches are becoming more and more logically similar, so we expect them to be pretty much one device down the road. Not before we're finished. We've got quite a bit of work to do with them as they are. So we know what routers do, connecting multiple sites, redundant paths, and ISPs. So we'll be looking a little bit at that. And then, finally, the last chapter of this course, we'll be looking at managing iOS files and licensing, because Cisco went after version 15. In version 15 releases, you can buy individual services. So if you need certain types of security, if you need traffic management, if you need any kind of specialty needs, they tend to build them into components now and add them to your license. And of course, you pay as you go. You pay for what you need. So anyway, that's a brief, I try to keep them brief, introduction to this chapter. I hope this is helpful and gets you going. Enjoy reading the chapter and getting up with the assignments, and of course the first Packet Tracer review from last semester.